Okay, good morning, team. Welcome back to our knowledge sharing. Today, I will share my experience in modeling and design of 3 simply supported span of reinforced concrete precast girder. This is the bridge section view. The first span is 21.6. The middle span is 22.3, and the last span is also 21. So there's a bit of symmetry, 21.6. It comprises of five precast eye girders, a slab of 225. These girders are all here. This is the girders mid span, and then it has a pier support, 2 pier support with tapering pier cap. This is a pier cap about 6.9 meters or close to 7. And then over support, you have over support you have a solid end girders with the diaphragm also indicated there. So basically, that is what I modeled. This bridge has been constructed, and also is already operational. You have seen on most of the posts on YouTube, there's a bridge on connecting Kaliro and Palisa. They call it Saka Bridge. This is the bridge that I think we worked on internally as the construction, as the in-house Yondra team, design team. We had all the key players, hydrologists, we had the highway team, we had the geotechnical team, the surveyors, the designers. So this is what we worked on, and it's actually being operational now. So that is the benefit of Midas, which is try to accelerate all these productions of designs and accelerating construction. So basically, the modeling process, it is very easy. You first do your sketches. You need to know members you are modeling, understand them, understand the material, understand the geometry requirements, section requirements, and the boundary condition, and then you do your artwork. Modeling is an art actually. Now on the left hand tree here, tree menu, I have works and works. You have the analysis control data, where you have the agent value analysis, because I think earthquake has been indicated there, dynamic loading. Then you have the moving load analysis data, your construction stage, because this bridge, you have the first stage, you build the bridge support system. This is your abutment simulated, and then this is the pile cap. This is the pile cap, and then after you have done, you build the piling system, you build the pile caps both, then you build what they call substructure system, the pier, and then you build the abutment, the pier, and the pier caps. So this is your first stage. So once that's done, you do your preparation, do all the deck system, prefabricate the girders. After you have done, you bring them, activate, bring them up here using crane, and that's what they did. Actually, we use crane. The contractor used crane to to lift all these, and you design for lifting as well, with proper anchoring system that you lift to avoid any bang, to avoid any deformation while in transit to the location, to avoid any deformation. So you take care of that, and extra bars may be required, so you have to design also for that. So after you have done all that, then you'll find that you put your, so the third, fourth stage, put everything. So once you have done constructed and it is already set, maybe then after maybe the 10,000 days, now the like 2, 3, 4 days, normally we take about 1 or 2 years. Once the concrete is set, then you are able now to put in the wearing cores, what we call superimposed loading. You put the raised walkways, you put the wearing cores, the services, and all other things. So basically that is that. Now, under materials, you come and do your materials. The materials will be identified. Kind of concrete, it is Euro coat. If you want another coat, you do that. And then I think for this girder we use compressive strength of 45 and ceiling at 35. And then that's what we did. And then being composite construction, there we had also time dependent materials like creep and shrinkage. So this is how the graph of creep and shrinkage, they're all given here. It's very important. It has to come. You see the end loading 10,000 days and the start loading 10 days. So basically that is what you need to include. Then you also have we have the compressive strength and a time dependent, because creep of this loading and other things you can find, you see that it's here. So this is our time dependent material with compressive strength. Mean compressive strength are given. The graphs is like that. So when you're reporting, you have to do all this. Okay, then material link. Once you have identified all that, make sure you link this material, and then they're up here. Creep shrinkage, you define that. You define compressive strength. You come and then I think if I can bring you here quickly, the link. This is where the link command. You make sure the creep is activated here. Then the compressive is activated. Select the concrete, bring it to the selected material here, and then add. So that is what you do with your linking. Okay, so that will be for materials. Then once you're done with that, you go to section. Under section, we have our pier cap. That is the pier cap definition. You define the pier cap. And then you need also to note that when you're dealing with pier and pier cap, the sections, if it is a tapering section, this middle section is uniform. And then this one is one that tapers. So you come to the tapering. So after you define, then this is where you look at the tapering. This is the tapering. You have that out here. It is this first one. The depth is 1.5 and the width is 2.1. Then at this point is uniform. It's 3 meters here. So basically that's what you specify. And then the main girder. This is the main girder. You go to PSC viewer. Then you need to know the spacing of the girder. You do here the thickness of the slab, the composite element. They are made here, but this one is composite I type. And then this is the composite. The first one is this girder, you can see. Then the second one, after you place these girders up, then you bring this wet concrete, and then you put that. That is what happened, and this material from all this have been specified. Make sure you also specify the reference point, center top, where measurements start from. You can see here. So that is what happened with the main girder. And girder detail, you also need to know. You can see this a bit because of shear value higher at this point. That is why it tends to be thicker, and that is what you need to take note of. And then you do this, modify all that in line with your bridge. You come to mid diaphragm. Mid diaphragm is here. You have it here. Specify And then we go down to, is there anything else? No, I think that is what need to be done now. Yeah, I think these are the key main element. This is the tapering. Now for the tapering section, because Midas does not design tapering member or section, and you just get an average between between the I type and this N type. You get the average thickness, and that's what you specify. Then so that you get at that particular point. But of course, you also you can break it further, smaller until you get all that. Instead, you have non-tapering sections which you simulate from the tapering. You just use the mathematical trigonometry approach to know the intermediate width and then the depth, so that you can specify and the software is able to help and design. Okay, so I think that is that, and then this is where your tapering sections are for the okay, fine. This is now when you're defining it in there. So sections are all defined. After you have defined all the sections, we now go to this boundary conditions. They're all here. This one you see this is your this is our boundary conditions. I think they're here because we are trying to simulate for the bigger support system. Here we're trying to fix this support, because later on we shall use the reaction values we obtain here after running the analysis, for us to be able to now correctly locate those the loading design, and then load the piles and pile cap, load the abutments and abutment pile cap and the piles using the reactions we obtain from this, and then you are able to model and to analyze and design. Sometimes you can model the all of this together integral to avoid the thing of other model at a later date doing the model of the foundation at a separate time. You do it at once, spend some more time and model it. With time we shall try to do one, and you see, so it will just get the right orientation, proper response, and you're able to holistically do all that thing, and then able to avoid opening many models. Just do one model and then run all the design at once. Okay, so once you're done with that, the elastic links are given here. These are the rigid connection, because you have to connect some of these things. You can see connecting the slab with the diaphragm, connecting it with the elastic links which simulate our bearings. That require some follow-up even on top of the PI support system. For you to have the rigid connections, the software designers have to come up with those design, and you can see now here they have those connections, so these members will act as one, and then you can then transfer. This is now how the load path is developed. So it goes to the pier. These reactions come in here. This reaction comes to the end reaction from these girders come to the bearings. The bearings are simulated using the elastic links, and then get onto the pier cap. From the pier cap gets to the pier, and then the pier system take it to the pile cap, and then the pile cap to the piles. So this is how it is done. If you want to get reaction out, then you don't model the pile cap. You remove it, and you do only now the support system of boundary connection only will be at this point, and then you are able to get that. So this is what normally, if you do from first principle, then you have to manually input all these all these boundary conditions. That's so now where Midas come handy, because using the wizard, Midas wizard, we tend to accelerate some of the things. So basically, this is what I think I can do for now, because of time management. We shall now go to the loading in the next session. So in a nutshell, understand the structure, understand X sections, load path, and then be able to also the exposure conditions, so that it guides you, the use of different codes of practices, literature, and some knowledge and notes from your lecture rooms. They help a lot. And then the other people who also understand some of the software very well, they also help you in case you get stuck anywhere. So modeling, this is what it is, and this is a construction stage modeling, your first stage. Then you go to your second stage, you do this other filling, what is required, preparation, then you do that, and then you're able to have this in place. That is briefly what we can have a look at. And then if you basically, I think, let me not go too much. Anything of analysis output will come when we have done the loading. Thank you so much.